Hey everyone, so today I'll be teaching you guys how to graph sinusoidal functions. These over here are the parent functions of sine and cosine, and since there's nothing manipulating the position or shape of the graph, this is what it will look like. This is the sine function, and the shape is based on the ratios of a unit circle, as you can see over here, because as theta approaches 90 degrees, hypotenuse gets closer and closer to 1, and so does the opposite side. 1 over 1 is 1, which matches this graph over here as sine of pi over 2 is equal to 1. And for here, as theta approaches 180 degrees, and we draw a triangle in the second quadrant, the hypotenuse approaches 1 again, but the opposite side approaches 0, and 0 over 1 is 0. So this also matches it. And if you do this for all the quadrants, you will realize that this graph matches up with the values. And from 0 to 2 pi, it cycles over and over periodically. So this is why we call it a periodic function as well. And as you can notice, this is the graph of the cosine function, and it's very similar to the sine function. And if we move this here, they're actually exactly pi over 2 from each other. So this distance from each other is pi over 2. So sine is actually just cosine shifted to the right pi over 2 radians. And cosine is just sine shifted to the left pi over 2 radians. The middle of the graph is called the midline, and in these situations, since it's a parent function, the midline is the x-axis. And the highest point in the graph is called the crest. So this spot and this spot. And the lowest point of the graph is called the trough, which is this and this over here. And the distance from the trough and the crest to the midline, which is this distance over here, which is this distance over here, we call that the amplitude. And this is also the amplitude. And in this situation, the amplitude is 1. And the length of the pattern is the period, and is 2 pi for this parent function over here, which is one pattern. Now shifting up and down is determined by this value over here. So the generic formula for the sine function is f of x equals a sine times period x plus c minus this value, we'll say d. These values don't mean anything, and I'm just using them as placeholders to teach you guys. Well, this d value over here would determine where the function shifts up and down. So if it were sine of x plus 2, it would shift it 2 units up, and if it was minus 3, it would shift it 3 units down. Shifting left and right are determined by the c value over here, and plus 4 would shift the function 4 to the left, and minus 4 would shift the function 4 to the right. It's the opposite of how this number functions, because if it's plus, it goes in the positive, minus goes in negative, but here it's plus goes in the negative, and minus goes in the positive. And the amplitude is determined by this a value over here. So in the parent function, the amplitude is 1, so the coefficient is 1, which is correct. So if the coefficient was 2, the function would just be taller, and so on and so forth. 3, 4, doesn't matter. It's the same concept. If sine of x becomes sine of negative x, it flips it on the y-axis, so it would actually look something like this, and would continue. And for cosine of negative x would look like that. Negative cosine of x will look like this. As for the period, which is the length over here, this length is the period, and in this situation, it's 2 pi. The value of the period can be calculated by 2 pi over the absolute value of, in this equation, p. Because in the parent function, the p value is actually just 1, and 2 pi over 1 is 2 pi, which matches up with here because the period, or the length of the period, is just 2 pi. And then, for cosine, it's the same concept. The period is 2 pi, and the coefficient is still 1. But if it were to be p equal to 2, 2 pi over 2 is pi, and it would actually look something like this. And the period would be 1 pi. Now, if it was 2 pi, next to the coefficient 2 pi over 2 pi is 1, and still the same concept. 1 is about here, and you would draw the function like so. Now let's do an example. Now this is the amplitude. Since this is the p value, 2 pi over 1/2 is 4 pi, so the period, or the length of the period, is 4 pi. So it takes 4 pi to complete the pattern. So instead of this, it would look much longer and something like that. And plus pi shifts it to the left by pi units, and -1 shifts the midline and the whole function down 1. So let's draw that. Over here is 1, and this -3. And the midline of the cosine function would be about here. And we would draw the x-axis based on the period. Since it's 4 pi, we would draw pi here, 2 pi here, 3 pi, and 4 pi. And then since it's shifted left 1, this would be -pi. And these would be the guidelines for drawing the function. Now, let's draw the function. It starts here because it was shifted left, but you must start at the midline, not the origin, because of the -1. So, now, each period is 4 pi, so it would go through the x-axis every 2 pi, which would make it look something like this. And then it goes up, back down. It would look something like that. And this matches up because the amplitude is 2, and the period is 4 pi. As you can see, 1, 2, 3, 4 pi. And -1, the midline is in -1. So yeah. And it was shifted left by pi units. So yeah, that's about it for the video.